All right, hello grade 10s. We are here, and we've got two things left this week. One of them is review, and then the test will be next week. So another short unit, which is good, I think. It's less stuff to try to wrap your head around and remember over the course of a couple of weeks. So hopefully that'll go okay. All right, triangles Gil and Bert are similar. If G is this, I is this, R is this, and T is this, determine the measures of the missing sides. So this is your first 5-minute question. Feel free to try it right now. Pause it and try it, and if not, I'll get you started. Okay, so let's draw two triangles. This is one, this will be Gil, and this will be Bert. Okay? Now let's put in the measurements. So G is 3.7 across from G. I is 8.5. R is in this triangle and it's 21.5. And T is 39.4. So obviously these aren't to scale, right? This side should be shorter than this, but it doesn't matter. I only did this so we know where all the information is. This would be side little l. I do a curly L because otherwise it looks like a 1. And this is side little b. Okay, so if you couldn't do the diagrams, maybe pause now and try. So here we go. I'm going to write my statement here. So G over B equals I over R equals L over T. Now notice I just got it from here. Gil is on top and Bert is on the bottom. And now I'm going to plug in. G is 3.7 over B, which is B. We don't know B. Equals I, which is 8.5, over R, which is 21.5, equals L, which is L, we don't know it, and T, which is 39.4. Okay, so what you should notice here, I'm going to zoom in, what you should notice is we've got three ratios, as we should. There's three pairs of sides. One of the ratios is complete, which is good because we need that. And each other ratio is only missing one thing. So this is an ideal situation. Let's solve for side L first because it's on top. So L over 39.4 is 8.5 over 21.5. And if this is like brand new to you, you need to go back and watch the other lessons because I'm going to go through this pretty quick. L's being divided, so we multiply. These cancel. But we got to do the same thing on the other side, or else we've broken math. And we go to the calculator and we do 8.5 times 39.4 equals, and then we divide by 21.5 and we get 15.6. So approximately 15.6. Okay? And now let's do side B. Side B is like, in quotes, the hard one, but it's not that bad because really we just have one extra step at the beginning. And that extra step is to get B on top. So we flip this fraction. But we can't just flip one side because then these things aren't equal anymore. So we have to flip the other side as well. While I'm thinking of it, I'm going to put a circle around that, and that'll be my therefore statement. I multiply by 3.7. That cancels out here. I multiply by 3.7 on the other side, and I go to the calculator. 21.5 times 3.7 divided by 8.5, 9.35, or B equals approximately 9.4. And that's that. Okay? So L is now 15.6, so that's smaller than the bottom one, which makes sense because this is smaller than that. And 3.7 should be smaller than B, and B is 9.4. So that makes sense. Also, the longest side in BRT is this one. The longest side is this one. So this should be the longest side. And if you look, 15.6 is the longest. 3.7 is the shortest. So B, 9.4, should be the shortest on the bottom. And that works out as well. So there's lots of ways to check to see if your answer makes sense. All right, here we go. Two triangles are similar if they have the same shape. Basically, one is an enlargement of the other. If two triangles are similar, their angles are equal. This is just a recap. You've already seen this. Here we go. Find the missing side length. So these two triangles are similar. So we would say that ABC is similar to DEF. Okay? So to find the missing side lengths, we've got A over D equals B over E equals C over F. Now, let me help you with this one because you don't have to do a lot of work here. This is 4 and this is 8. How do we get from 4 to 8 by multiplying? Well, we multiply by 2, right? So all we have to do to get the missing sides is to double these numbers. So this is going to be 10. We double this. This is going to be 6. We could do this. Plug everything in and solve, but that's not what I'm trying to show you right now, so I don't want to spend too much time because I know you don't want to spend too much time listening to me talk. So find the perimeter of each. So I'm going to call this triangle 1 and this triangle 2. So P1 is going to be 4 plus 5 plus 3. We just add everything up. And that's going to be 12 centimeters. And P2, which is double the size, well, you would think that the perimeter would be double. 18, 24. It is double. Awesome. Let's do the area of triangle 1. Remember, area equals base times height divided by 2. And I've given right triangles, so this is easy. The base is 3. The height is 4. We divide by 2. So 12 divided by 2 is 6 square centimeters. And now let's do A2. Well, A2 is double the size, so it should probably just be 12, right? Let's check just to make sure. Base times height divided by 2 is going to be 48 divided by 2 is 24. What? So the perimeter doubled, but the area quadrupled. Well, that's surprising. The perimeter doubled, but the area quadrupled. What is going on? Well, let's keep going. So we can conclude that if there's a pair of similar triangles and the larger triangle's sides are double those, the area is 4 times. So perimeter double, area quadruple. So what do you think the general case would be? Now, I'm sorry, this is going to be quicker than I would like. But if we did this in class, like, it would be a whole thing. You'd get a bunch of examples, but I know a lot of people don't want to spend that kind of time right now, and without me there to supervise, I don't know how well it would go. So I'm going to tell you this. If the perimeter is 3 times, then the area is, I would love for you to pause and try to figure this out. Okay, hopefully you thought about it. So if the perimeter is tripled, the area is actually 9 times. And if the perimeter is 4 times, the area is 16 times. And if the perimeter is 5 times bigger, the area is 25 times bigger if the perimeter is 5 times bigger. So we get this by taking the ratio of the sides and S, A, I, G, U, N, R, Q. We square it. So perimeter is 3. 3 squared, or 3 times 3 is 9. Perimeter is 4 times 4, or 4 squared is 16, etc. This works with any ratio. If there was a triangle with sides 3 times longer, its area would be 3 squared, or 9 times larger. If there was a triangle with sides 4.1 times longer, its area would be 4.1 squared, or 4.1 squared is 16.81, or 4.1 times 4.1 is also 16.81 times larger. This is like most of today's lesson. Let me show you how this works. So check this out. You can see here that the perimeter is double. Okay, so hold on. This is triple. right? The sides are 3 times bigger. I changed this, but I didn't change the word, so let me fix this. Okay, so the perimeter is triple. So what I want to see is how many of these triangles can I fit in? Well, I can fit along the bottom here, because it's 3 times longer, I can fit 3 along the bottom, right? And because it's 3 times taller, I can fit 3 up the side. And then what I do is I go in and I just keep putting triangles wherever I can fit them. And I've got these spaces, and what you might be able to tell right away, whoop, I can flip them upside down and put them in. And there you go. So now you can count, right? So this is 1. This is 3. So it's 3 times as wide, 3 times as tall, 3 times on the angle, and let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9 times the area. So there you go. So that's kind of a way you can think about it. If you think about it with a square as well, right? If we take a square and we double the height of the square, how many times will this little guy fit in here now? It's only twice as big, but it's twice as long and twice as tall. So 2 times 2 is going to give 4 of these terribly drawn squares will fit in there. And hopefully you see my point. All right, let's get to your handout. I have 2 examples, and then for you I have one homework question, and that's it. Okay? It's an easy concept. It's a quick day. We're only 12 minutes in, so let's get this done. All right, so practice number 1. These 2 triangles are similar. Write the ratio of corresponding sides. F over, so this means that FGH is similar to RST. So F over R equals G over S equals H over T. Corresponding angles, F equals R, angle F equals angle R, angle G equals angle S, and angle H equals angle T. Find the missing side lengths. I would like you to do that. Actually, no, there's a trick here. Let me help. All right. So first, let's find F. Okay. So we don't know R and we don't know F. So we can't use similar triangles to solve for this. But we can use the Pythagorean Theorem. Remember the Pythagorean Theorem? Yeah. All right. So a squared plus b squared equals c squared. Remember, c is the hypotenuse. So let's plug in here. A is going to be 6. So 6 squared plus b is going to be f plus f squared equals 13 squared. Now we solve for f. So 36 plus f squared equals 169. We subtract 36 from both sides. And f squared equals 169 minus 36 is 133. So now you're going to say, oh, f is 133. It's not, though. Take the square root of both sides. And f equals the square root of 133, which is 11.5, approximately. Okay, so if f is approximately 11.5, then r equals approximately 11.5 times, let's take 2 decimal places, 11.53. So 11.53. Now obviously you can see here this triangle is double, so just times 2. And r is approximately 23.06. All right, let's look at the follow-ups. Calculate the perimeter. Okay, so this is triangle 1. P1 equals approximately, because we've got decimals, P plus 13 plus 11.53. P1 equals approximately 11.53 plus 19. 30.53. Now, this one should be double that. So it should be 61.06. but let's figure it out. So P2 is approximately 12 plus 26 plus 23.06. So 12 plus 26 plus 23.06. 61, that's exactly what we got. So P2 is approximately 61.06. Now we will find the area. So the area of the first one is the base, which is 11.53. Remember, the base is always the bottom side, times the height divided by 2. So 11.53 times 6, cut in half, we get 34.59 units squared. And then A2 is approximately, that's triangle 2, 23.06 times 12 divided by 2 equals, so 23.06 times 12 divided by 2 is 138.36. And now the big question, kind of the point of today, how many times larger is the area of the bigger triangle? So to do that, we do A2 divided by A1. So A2 is 138.36 divided by the area of the first one, we get 4. And how many times larger is the perimeter? So we do the bigger perimeter divided by the smaller. So 61.06 divided by 30.53, 2. And that's what we would expect, right? If the perimeter is double, or if the sides are double, the area should be quadruple. Okay, last one that I'm going to do here. So we've got x, y, z is similar to MNO. So x over m equals y over n equals z over O. Corresponding angles, x equals m, y equals n, and angle z is angle O. Find the lengths of the missing sides. Well, let's see here. How do you get from 8 to 16? Times 2. So 10 times 2 is 20 centimeters. And you might remember that these little ticks tell us that the sides are the same. Okay, check. Calculate the perimeter. So P1 is going to be 28. I just did 10 plus 10 plus 8. And P2 is going to be 56. Okay, I know I'm rushing through this part, but that's because the next is the hard part. I'm going to spend some time here. Calculate the height of each triangle. So remember, this is 20. This is 10. This is 20. Now the height. So this is like probably the hardest part about today, but it's actually from way back when. We did this a lot at the beginning of the year, I believe. To do this, we need a right triangle. So let me draw it over here. Okay, so obviously the slant is still 10, right? The slant is 10. But the question is, what's this? And it's not 8. What is it? It's 4. Okay, and we'll call this H. So, are we looking for the long side or a short side? We're looking for the short side, so we have to subtract. So h squared is 10 squared minus 4 squared. Remember, this is just Pythagorean Theorem. So 100 minus 16 is 84. And I take the square root. So 84. And I take the square root. 84. I take the square root. And I get approximately 9.17. Now, here's my question. Do you have to find the height of this one by doing the Pythagorean Theorem? I don't think you do, right? The triangle's twice the size, so you should just be able to double it and get 18.34. So let's write that, and let's check it. So for that one, we're going to have another right triangle. The slant height is 20, and this is going to be half of the bottom, which is going to be 8. We'll call this h again. So h squared is 20 squared minus 8 squared h squared equals 400 is 20 squared, minus 64 is 8 squared, 336. And now I got to take the square root of both sides, and I get, whoa, I get 18.33. Now, if you look at what I got before, I got 18.34, and you might think, oh no, something went wrong, but it didn't. Of course, it was just rounding, so you don't even have to worry about that. All right, now find the area of each triangle. So the area of triangle 1 is the base, which is 8, times the height, which is 9.17, divided by 2. So 9.17 times 8 divided by 2 is approximately 36.68 centimeters squared. The heights would have been centimeters. A2 equals the base, which is double, times the height, which is approximately double, divided by 2. So notice, we doubled, and then we doubled again. So times 2 times 2. So that's why the area works out to be times 4. So 16 times 18.34 is that, divided by 2, 146.72 centimeters squared. How many times larger is the area of the bigger? We do A2 divided by A1. We should get 4. 4! And how many times larger is the perimeter? So we do the bigger perimeter divided by the smaller perimeter. Where's the perimeters? There. So 56 divided by 28 is 2. Sweet. Okay, and here is your homework. It is one question, one big question, and it's basically the same thing that we just did, where you have to find the height. But you'll notice this triangle is not just 2 times the size. So be careful with that, okay? All right, so please give that a shot. I'll post the solutions later on today. And as always, email me with any questions that you have. Good luck, folks.